Welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module, that is the object oriented module, and the same chapter, that is the chapter number 8, inheritance. In the last class we have started this chapter and we have done one example of single inheritance, that is how inheritance is applicable in the C++ programming. And this is one of the important chapter of the C++ or any language that is covered under the object oriented. This is one of the major or the important feature that is available in the object oriented programming, right? So let's start with some basic concept that we have covered in the last class, that is go through with the basic of the last class, that is what we have covered, then moves to the today's part, that is how to make the permanent or single inheritance member, or how to make them protected, that is how to make them the protected members. So let's start with the previous class session. In the last class we have started with chapter number 8, that is inheritance, right? So first of all we have studied what is the meaning of inheritance. As the name advises, inheritance, that is extended classes or extending the classes, that is the classes will be extended from one part to another, from one form to the another, that is one existing class can be extended, that means carry forward to the next class, so that the features of the one class can be carried forward to the next class, that is extending the classes. And in introduction we have studied in that reusability is one of the major advancement or major feature or important feature of the object oriented programming. If we are able to reuse the system, reuse the application, then it is very easy to cope up with the various concepts that is used with the e-commerce, that is used with the object oriented programming. So reusability, why? Because if we develop, or if the programmer develop or design one function, if that function is also applicable, that function is used again and again in more than one places, in more than one program, so it's better to write that program. For example, if there is a program that is addition, so the same addition will be performed in one program to perform the addition of two numbers. In the same way, the same addition is performed to add the various values that is available in the next program. So it's better to reuse the system, reuse the same class, reuse the same function again and again. That is the reusability. That is an important concept of, or important aspect of, a feature of object oriented programming. So what are the various advantages? It would not only save the time, it is one of the advantages that it is only the save the time and the money, but also reduces the frustration and increase the reliability. That is, most of the time the programmer frustrate with developing the program, designing the program, writing the code for a program. So that also, or this one not only saves the time and the money of the program or of any organization, marketing manager, any manager, but it also reduces the frustration that may be in the mind of manager, in the mind of programmer, anyone, and also increases the reusability or the reliability, so that everyone can rely on the data, on the object that is used by the C++ or that is used by the inheritance, right? Then fortunately C++ strongly supports the concept of the reusability. That is, C++ provides the concept of reusability, that is the same class will be reused again and again to provide the given solution. That is the reusability. The C++ classes can be reused in various ways. Once a class has been written and tested, it can be adapted by other programmer to suit their requirement. So once a class is defined, when a class is built, so it can be occupied by other programmer, occupied by or used by other programmer to find their or to suit their requirement, to satisfy their requirement. That is basically done by creating the new classes, reusing the properties of the existing one. That is, first of all, for example, if one class is created, I have created one more class that has own features, that has its own feature, that is, they contain their own features as well as a supporting feature of the previous class, that is a inheritance, right? So mechanism of deriving a new class from the old one is known as the inheritance or the derivation. This is one of the important line. So whatever the mechanism that is used to derive a new class from the old one, that is known as the inheritance or derivation. The old class is referred as the base class. Any old class that is used, that is referred as a base class, and the new class that is used as a derived class. So one is the base class, one is the derived class. Base class is also known as the superclass, and the subclass is also known as the derived class. So there are two classes. One is the parent class, that is the base class or the superclass. One is the child class, derived class or subclass. There are multiple names, but keep in mind whatever the class that provides some feature, that is a base class, that is a top class, and the class which gathers all the feature, that is known as the derived class or the subclass, right? Then we have studied about that derived class also contain its own feature, also get the feature from the base class. That is, the derived class inherits some or all of the features from the or traits from the base class. It's not mandatory that every feature is adopted by the or from the base class. Yes, it is adopted, it is inherited, but it's the option of derived class that this class or that class is able to cope up with that features, data member functions or not. A class can also inherit from more than one class or from more than one level. That is, if or if there are more than one classes, that is derived, or if there are more than one classes, that is derived from the single base class, that is also inheritance. So inheritance is divided into 5 parts. These are the various 5 parts. One is the A, B, that is as the arrow advise. The B, that is the B part, is inherited from the A. So the B class is inherited from the class A. Then multiple inheritance. Then there are 2 base classes and there is one derived class. That is, A and B are the 2 derived base classes and the C is the derived class. Then there is a hierarchical inheritance. There is a single base class and there are multiple derived class. So there is single base class, that is A, and there are multiple derived class like B, C, D. That is a hierarchical inheritance. So one is single, there is one base class, there is one derived class. There is a multiple, that means more than one base class and there is one derived class. Then hierarchical, that is there is only one base class and there are multiple derived classes. Now next is multi-level, that is a one base class becomes a derived class for another. That is a multi-level. That is, it works as a derived class for class A. It also acts as a base class for class C. That is the A, B, C. Then this is a hybrid inheritance. That is the A, B, C, D. That is a combination of the base classes or the combination of various classes. That is a combination of the hierarchical inheritance as well as the multiple inheritance. These are the various forms of inheritance. Then we have discussed about how to define the derived class, that what are the various features that is used or what are the syntax that is used to define the derived class. This says a derived class can be defined by specifying its relationship with the base class in addition to its own detail. The general form of defining a derived class is as follows. So this is the general form that is used to define the derived class. So the syntax is, there is a class word, that is a class keyword, then there is a derived class name, that is the name of the derived class, then there is a visibility mode, then there is a base class name. That is, one is a derived class name, then visibility mode, that may be public, protected or the private. Then there is a base class name, and then there is a curly braces, and then members, whatever the members of the derived class, and there is a closing curly braces, there is a semicolon. So this is the structure, this is the syntax of the derived class. This is the syntax of the inheritance, that is a single inheritance. The colon indicates that the derived class name is derived from the base class name. That is, the derived class name that is given is derived from the base class name. The visibility mode is optional. So this is optional, and if present may be either private or public. The default visibility mode is private. So whatever the default visibility mode, if nothing is mentioned, that is means it's a private. Visibility mode specifies whether the features of the base class are privately defined or derived or publicly derived. That it can specify, or the visibility mode specifies whether the features of the base class are privately derived or publicly derived. So it depends. It may be declared as a private, it may be declared as a public. This is example. This is a private declaration. That means there is a private, then XYZ. Then there is a members of the ABC, because ABC is a derived class and this is the base class, because the syntax is derived class and then visibility mode and the base class. So this is the derived class, this is the visibility mode, this is the base class. So when the base class is privately inherited by a derived class, public members of the base class becomes private members of the derived class, and therefore the public members of the base class can only be accessed by the member functions of the derived class. They are inaccessible to the objects of the derived class. Remember, a public member of a class can be accessed by its own object using the dot operator. That is, they are accessed or they can be accessed by using various operator, by using various terms, that is using the dot operator. On the other hand, when the base class is publicly inherited, that is, when the base class is publicly inherited, the public members of the base class become public members of the derived class, and therefore they are accessible to the objects of the derived class. In both the cases, the private members are not inherited, and therefore the private members of the base class will never become the member of the derived class. That means when it is publicly inherited, the public members of the class have base class have public member or become public member of the derived class. That is, when it is privately declared, so public members of become the private members. So that can be accessible by any of the functions that is used in the derived class. First of all, clear this one, that is, if it is privately inherited, then the public members also become the private members of the derived class. They are inaccessible to the objects of the derived class because they are private members. That is, there is no member that can be accessed by the derived class. But it is next case is when it is publicly inherited, then the public members of the base class becomes a public member of the derived class, and therefore they are accessible to the objects of the derived class. That is, the object of the derived class are accessed, or the member functions of the public members are accessed by using the dot operator of the derived class. In both the cases, private members are not inherited, and therefore the private members of a base class will never become the members of its derived class. That is, a private member are not inherited. That is, the data members are generally the data members are not inherited in case of public. That is, or that not becomes a part of the, or that not becomes a member of the derived class. In inheritance, some of the base class data elements and member functions are inherited into the derived class. When we add our own data and the member functions and thus extend the functionality of the base class. Inheritance, when used to modify and extend the capabilities of the existing class, becomes a very powerful tool for incremental program development. So that is the inheritance. So reusability of the class, reusability of the various code capabilities to modify and increase the capability of the existing class, that is very powerful tool for the program development. Then next is single inheritance. That is, a single inheritance means there is one base class, there is one derived class. That is a single inheritance. Let us consider a simple example to illustrate the inheritance. So this is a single example that we have discussed practically also in the last class, that is how to use the single inheritance. So this is the function that is used. There is a class B, then there is the int A, then public int B. That is, the int B is the private member, and the small b is the A is the private member, and B is the public member. And there are three member functions that is used. One is the get AB, one is the get A, then there is a show A. Then there is the closing of the class, and there is a closing of the semicolon. Then class D, that is a new derived class, there is a scope resolution operator, then public, then B. Then there is one data member that is known as the C, int C, and there are two member functions, that is a mul, that is a multiply, and the display. Then again there is a closing curly braces, and there is a semicolon. Then this is the definition of get AB, that is getting the value or storing the values of A and B. Then again the get a function that is used to simply return the value of a or displays the value of a. Then show a, that is used to show the a value. So this simply returns the value. This is used to show the value, that is display the value. Then multiply function, that is the a and the b is multiplied, that is the b into get a, and the get a contains the return a, or the return, or the it is return or return the value, that is the get a. This is the get a, then return the a. And then display function, first of all the a will be printed, then the b will be printed, c will be printed. So what is the value of a? That is simply the whatever the value that is given, then value of b, then value of c, then it is multiplied together, that is stored in the c, that is a and b are multiplied together. Then there is a int main function that is used. Then there is a d, that is the object of the d class or the derived class d is d. Then d dot get ab. Yeah, students, I'm just coming within 2 minutes. So this d is the object of the class d. This small d is the object of the capital class d. Then this is calling the function, that is get ab, then multiply, show a, then display, and then assigns the value of 20 to b, then multiply. That means first of all it is multiplied, that is the value that is given over here, that is the 5 and the 10. Now the value of b will be changed in the by the use of the object, that is the d dot b equals to 20. Then again uses the multiply function, or again calling the multiply function and the display function. Right. This is the output that is given. First of all it is 5, then 10, now it is 5, 20 and 100. The class D is a public derivation of the type of base class B. Therefore D inherit all the public properties of the B and retains their visibility. So this is the explanation of this one. That is the private section D, and then public section. Now this is also the example that is given. This is just explanation of whole program, that is what is the how it is used, how it is inherited, how to use the data members. Now we have also taken that how to use the single inheritance, that is a private part. The next is how to use the or how to inherit the properties when the visibility mode is private. So this is a private, that is a class D, that is the name of the class, and there is a private, then there is a B, then int C, then public, void null, that is a void, and then void display, there is a void. So private is the private declaration, that is privately it inherit all the data from the upper class, that is a base class, but it is private. Now the every public member also becomes a private. Right. So this is the private declaration. This is the private declaration, that is privately it is declared, or private it can inherit the data. So the public members are also become the private members. So no other class other than the class D can inherit the or can access the properties, can access the data members and the member functions. Now how to make the private member inheritable, so that if I want that the private member needs to be inherit. So till now we have covered that the public members are inherited, but if I want that private member also inherit, what is the use, or what is the content, or what is the criteria to use the private members, right? So making a private member inaccessible. So we are just seeing to how to increase the capabilities of an existing class without modifying it. We have also seen that the private members of a base class cannot be inherited. We have covered that the private members cannot be inherited. Only the public members are inherited, right? Therefore, it is not available for the derived class directly. That is, they are not accessible by the derived class directly, because they are the private members, so it cannot be inherited for the derived class. What do we do if the private data needs to be inherited by the derived class? That is, what should we do if the private data need to be inherited by the derived class? So if there is a requirement of the derived class that inherit the private data, so what is the solution? So C++ also provides a solution. So this can be accomplished by modifying the visibility limit of the private member by making it public. That's what makes it accessible to all the other functions of the class, therefore taking away the advantage of data binding. So that means if I want to use the private member, so that becomes a public. But if they become the public, then it can be accessible by everyone. So there is a lack of the data security, lack of the data binding, or the lack of the data abstraction. So what can we do? So C++ provide a new visibility modifier, that is a third visibility modifier, that is a protected. So C++ provides a third visibility modifier that is known as the protected. So there are three modifiers. One is public, that is when the public is used, every members or every public members of the base class are inherited by the derived class. When it is private, every public member becomes a private members of the derived class. But third modifier is the protected, which serves a limited purpose in inheritance, that is, which is used for the limited purpose in the inheritance. A member that is declared as protected is accessible by the member functions. So member that is declared as a protected is accessible by the member functions within a class, and any class immediately derived from it. That is, any member that is declared as protected is accessible by the member function that is within its class, that is given within the class, so that can be accessible by the member functions within its class. So what is the advantage? That the every member functions is inherited, or the every member functions is used within the class, and any class that is immediately derived from it. It cannot be accessed by the functions outside two classes. So that means if we use the modifier, if we use the visibility level modifier or visibility modifier that is protected, so that is whatever the values that is given, whatever the data members and the member function that is taken, that becomes protected, that can be accessible or that can be used within two classes, not more than two classes. So it cannot be accessed by the functions outside these two classes. A class can now use all the three visibility modes as illustrated below. So this is an example that use all the three visibility modes. So one is class alpha, that is a class name is alpha. So one class is defined that the name is alpha class. Then there is a private members. So this is optional, visible to member function. So this is optional, not mandatory to write the private part. Then visible to member function, that is with its class. Then protected, then visible to the member functions of its own and the derived class. That is, the member functions are visible, are occupied, are carried out, are inherited only by the base class and the derived class. Then next is public, that is visible to the all the functions. That may be a member function, that may be a normal function. So public part can be visible by any of the function to all the functions. Then next is these are the three modifiers that is used. One is the public, one is the protected, one is the private. Public, that is accessible by any of the function of all of the function in the program. Protected, that is visible to the member function that is of its own and the derived class. Then there is a public, that is visible to all the programs in the or to the program. That is everyone can access the program, everyone can visible the member function that is used in the program, right? So when a protected member is inherited in the public mode. Now next is how the protected member is used in the public mode, because public mode is visible to all the function that is available in the program. But what happened if there is a protected part, if there is a protected program, right? So when a protected member is inherited in a public mode, it becomes protected in the derived class too, and therefore it is accessible by the member functions of the derived class. So when a protected member is inherit, it becomes the protected in the derived class, and therefore it is accessible by the member functions of the derived class. It is ready for the further inheritance. That is, it also provides a multi-level inheritance. That is, one inheritance is provided by the another inheritance. A protected member inherit in the private mode. So any protected member that is inherit in the private mode becomes a private in the derived class. So when it is inherited in the public mode, it becomes protected, but when it is inherited in the private mode, it becomes private in the derived class. Although it is available to the member functions of the derived class, it is not available for further inheritance. But when it is used in the inherit in the public mode, it is also used for the further inheritance. But when it is available to the member functions, or it is privately accessed, it cannot be accessed, it cannot be used, or it is available only to the member functions of the derived class. Figure 8.4 is a pictorial representation for the two levels of derivation. That is, what are the two levels of derivation, what are the two usage of variations, or what are the various two parts of the variation or derivations or inheritance. So this is class B. There is a private member that is not inheritable, right? Then protected, there are two parts. One is a protected, there are three modifiers basically. One is a private, one is a protected, one is the public. So the protected is used to define the values. So when it is accessed in the public mode, there becomes a public mode that can be accessible by every function. When it is a private, that can be accessible by various functions. So this is the protected, and this is class D1, that is publicly inherit the properties of the B. This is publicly inherit. So this is the private part, this is the protected part, this is the public part. This protected becomes the protected over here, right? Now when it is privately declared, these protected members become the private over here. So this protected member also becomes the private, but that cannot be accessible by any of the functions or by any of the function that is defined in the class. But when it is publicly used, so it can becomes the protected, and that can be accessible by the both the base and the derived class. Then this is class X, that is publicly declare the D1, and the protected, that is protectically, or the protected in a protected way, it is used the D2. So that is D1 and the D2. So this is the we can say the hierarchical inheritance, that is more than one base class. No, not hierarchical, that is a multi-level multiple inheritance, that is more than one base class and there is only one derived class. That is class X is taken from the all the features from the D1 and the D2. And the D1 is the public and the D2 is the protected. So it also contains three parts. One is the private, one is the protected, one is the public. When it is protected member, that becomes protected, public member also become protected, and the public member becomes public. Now this is the effect of the inheritance on the visibility of the labels or the members. So remember, listen carefully, this is the important part. When it is the protected members are privately, when the protected members are publicly inherit, then the protected members become the protected. When it is privately inherit, the protected members becomes private members. The keywords private, protected and public may appear in any order and any number of times in the declaration of a class. So this is may appear in any order and any number of times in the declaration of the class. This is the example. That is, class beta is used, one is protected, then again public, then private, then again private. That is no limit that it is or any data member that is defined in public, that define in only that part only. No, we can use any specifier n number of times. That is any visibility modifier n number of times. That is public, private and the protected. It's a valid class definition. However, the normal practice is to use them as follows. That it is a normal practice. There is a class beta, then there is a private by default, then there is a protected that is used, and then there is a public. So it is by default that there is a private members, protected members, and the public members. That is, when nothing is mentioned, that means a private members, and the protected is specifically allotted, and the publicly is also specifically allotted, that is used. So these are the three specifiers, visibility modifiers, that is the private, protected, and the public. So it is also possible to inherit a base class in the protected mode. So it is also possible to inherit the properties of the base class in the protected mode. That is known as the protected derivation. In protected derivation, both the public and the protected members of the base class becomes protected members of the derived class. Table 8.1 summarizes how the visibility of the base class members undergoes modification in all the three types of variations. Now let us review the access control to the private and the protected members of the class. What are the various functions to these verifiers or these modifiers that is used, that is the private and the protected? They could be a function that is a friend of the class. So what are the various access control to the private and the protected members when the member is declared as a private and the protected? So what are the various functions that can have access to these members? They could be a function that is a friend of the class. They could be a member function of a class that is a friend of the class. They could be a member function of a derived class. So any function that is a friend of the class, any member function that is a friend of the class, any member function of the derived class, anything. While the friend function and the member function of a friend class can have direct access to both the private and the protected. That is the friend function if it is used, and the member function if it is used of a friend function, that have a direct control, direct access from the both the private and the protected data. The member functions of a derived class can directly access only the protected data. However, they can access the private data through the member functions of the base class. Figure 8.5 illustrates how the access control mechanism works in various situations. That is, how there is a access control, that is used in various conditions. A simplified view of access control to the members of the class is shown in figure 8.6. So that is a simplified view, simplified version of the access control. Table 8.1, that is a visibility of the inherit member. That is, what is the visibility that is used? This is the derived class visibility. There is a public declaration, there is a private declaration, there is a protected declaration. This is private members when it is publicly derivated or publicly derived, that is not inherited. In a private mode, it is also not inherited. In the protected mode, it is also not inherited. That means if the base class members are private and it is publicly inherit or publicly derivative, that is a publicly inherit, that cannot be inherited. In the privately, it is also inherited. Protected, it is also inherited. Then if the protected members of the base class is accessed by using the modifier that is a public, that can be accessed and becomes the protected. When it is privately accessed, that becomes the private. When it is protected access, that is becomes the protected. Now next is publicly. When it is publicly accessed or the public members are accessed, that is publicly accessed by the public derivation, privately accessed private derivation, and protected access is protected derivation. This is the most important figure, that is shows the base class and the derived class relationship. This is the same example. Now this is the single inheritance we have finished. That is the one type we have finished, that is a single inheritance. So let's take a break right now, then move to the practical approach of the class, that is how to use the practical approach, or how to use the C++, or how to use the concept of class in the C++. So first of all, let's take a break, then move to the practical part. So let's take a break right now. So come back from the break. Now let's start the session again. So now let's see what is the let's see some practical approach about the constructor. We have covered the constructor in a theoretical way. So now we will discuss the constructor in a practical way. So now let's start with the basic, the practical term, practical concept of the C++. So this is the example that shows how to use the constructor or how to use the class with the constructor, right? That is how to use the classes with the constructor or how to define the class with the constructor. Now, if I'm using hash include, that is stdio.h, then hash include conio.h, sorry, I'm so sorry. This is not stdio, this is iostream, right? And then there is a class that is declared, for example, class integer. So the name of the class is integer over here. So the class that is declared is an integer. So there is a class that is an integer, right? Then there is a variable that is private member that is declared, that is the m and the n. So this is private members. Then there is a public declaration that is defined, or that is define the constructors. So one constructor is defined, that is a int, that is they takes two argument, two are of integer type. This is a constructor. How do I know this is a constructor? Because the class name is also the same, that is an integer, and this is also the name. So whenever there is a constructor that has a various, or that has a main capability, main quality, main feature is that its class name is very similar to the, or its name is very similar to the class name, that is an integer int, right? Then there is a void display, that is a void, then display. Then there is a void that is written over here. Then there is a curly braces. Now cout, that is cout, this that will display, that is m equals to, then displaying the value of m simply. Then there is a inverted commas, then there is a slash n, that is a backward slash n. Now again there is a cout, then n equals to, that is n, then there is a slash n, then there is a semicolon. That means m and n values are printed, and this becomes an inline function. Why? Because the display function is used or defined inside the class, so that becomes a inline function. Then there is a closing curly braces, there is a closing a semicolon. This means this is one of the class in which we declare the data members, we declare the public members, data member, that is a member functions, and the one of the member functions is defined, and one of the constructor that is used. So this is a constructor declaration. So can I say constructor declare? Now next part is constructor define, that is the integer. Then there is a those two scope resolution, then there is a integer, then there is a int x, int y, then there is a curly braces that is open, then m equals to x, and n equals to y, right? Then there is a closing of the curly braces. Then there is a int main, then there is a closing of the curly braces, opening of the curly braces, that is the main function. Then integer, int1, then there is a 0 and the 100. So there are two values, that is a 0 and the 100, that is passed. This is a parameterized constructor. that is implicit constructor or the parameterized constructor. Then next is explicit constructor, that is integer into that is equals to integer, then there are two values, that is 25 and 75. Then there is a closing curly braces, then cout, then object 1 will be displayed as it is, object 1, then it is used in the next line, that is it is used for the next line, that is used, that is /n, that is the object 1, then there is a int1 dot display, that is dot operator is used, then dot display, then again then cout, object 2, then there is a /n, then again next function or the next category that is used, that is a int2 is used for display the function, that is a display function, then there is a get ch, then there is a return 0. First of all I save and then mute the Joseph. What Joseph? How many sounds are available from you? This is also available from the Larry side. What happened? So we have covered only one program right now, that is a constructor. Now let's see. This is a constructor. So now let's see what is a constructor. So first of all, two header files are included, that is the iostream.h and the conio.h. Then there is a class, and the class name is integer, that is a class integer, and there are two private member that is used, one is the m and one is the n, that is the m and the n. Then public, that is a publicly it is declared, there is a constructor that is declared, that is the integer int. So the name of the constructor is integer and there are two arguments that is used. One is the of int type, another is also of int type, that is used with the this one, that is the int, right? That is a constructor defined, or sorry, declared. Then there is a member function that is used, that is a public part, it is defined over here only, that is this becomes the inline function, that is a void display, then there is a void, then cout m equals to, that is the m value will be printed, n value will be printed, that is the m equals to, n equals to, then the m and n are printed, that is a display function. Then there is a closing of the class, that is a closing of the curly braces, and there is a semicolon, right? Then there is a integer. So this is the syntax, or this is the standard format that is used for declaring the constructor. So this is we have used, that is a constructor definition. That is the integer, int x, int y. So there are two variables, two argument that is given, that is the x and the y, that is the int x and the int y. Then there is a m equals to x, that is the x value will be assigned to the m and the y value will be assigned to the n, that is the x equal or m equals to x and the n equals to y. Then there is a int main, that is the main function will be starting. Then there is a integer int 1 0 100, that is the one we can say the one object can be created, that is the int1, that takes two arguments. So this is the form of the implicit constructor, or we can say the implicit conversion is taken place. How do I know? Because over here only in parenthesis it is given the value, that is a 0 and the 100. There is no requirement of the another name of the constructor. This is known as the implicit constructor, that is the integer int1. So integer is the name of the class and int1 is the object, and there are two values that is given, that is stored in the m and the n, that is the 0 and the 100. Why m and the n? Because whenever this is used, so this directly calls a function to this one. This directly goes to over here. There are two values, x and the y. 0 is assigned to the m and the 100 is assigned to the n. Then integer into equals to integer 2575. Then this is known as the explicit constructor, that is the explicit way it is used, that is the into, that is the name of the object, that is equals to the integer 25 comma 75. So this is another name that is given, that is the integer, and there are two values, that is the 25 and the 75. Now after this is also calling the another function. Now the m contains 25 and the n contains 75. Then see out object1, that is this will display as it is, that is object1. Then int1 dot display. So this is used to call the function, that is a display function, that is a display. Then see out m equals to m. So this m will be printed, then n will be printed. So for object1, this int1 will be used, so this will print the values like 0 and the 100. Here in object2, int2 will be used, so this will display the values of the object2, that is the 25 and the 75, that is the int2 dot display. Then there is a get ch, that there is a return 0, right? Now if I compile this code, there is a alt F5, there is no output. If I compile, that is alt F9. This is object1, and that is m equals to 0, n equals to 0. In object2, m equals to 25, n equals to 25. So this will display as it is over here. Now if I give over here, now if I compile this code, if I execute this code, this will display in the next line, but there is no clear screen, so I have to give the clear screen over here, that is CLR SCR. So this is like this one. Object1, m equals to 0, n equals to 100. Object2, m equals to 25, n equals to 75. There are two values of object1, there are two values of object2. Right, so this is the example of the constructor. Now everyone, this example is clear to you, Joseph and the Larry? Whether this program is clear to each and everyone? Pardon? Okay, Larry. What about Joseph? It's clear? Okay, thanks, Joseph. Now the next is how to use the overloaded constructor, that is how to overload the constructors, or that means more than one constructor at the same time, or more than one constructor in the same program. That is the overloaded constructor, right? So let's start with the overloaded constructor. There is a hash include iostream dot h, then hash include conio dot h. Then there is a class, that is a class complex. Then there is a two variable that is declared, that is the x and the y. Then in a public declaration it is given, there is a complex, then there is a closing curly braces, and there is a blank parenthesis over here, because there is no, this is known as the default constructor. This is also a constructor. Then we can say over here that is a default constructor. Now there is a complex, there is a float a, then in a parenthesis this is given, or this is assigns a value of x equals to y equals to a. That is, all the values are, or a is assigned to the this one, that is the a and the v. Then there is another constructor that is used, that is a complex. Then there are two arguments, then float, real, float, imaginary. Then again there is a curly braces that is used. Then x is assigned the value to the real, or the real value is assigned to the x, and the imaginary value is assigned to the y. Then there is a closing curly braces, right? Now one more friend function is declared, that is a friend, then complex, then there is a sum, that is complex, right? Then there is a semicolon that is used. Then again there is one more friend that is used. Then there is a void show. Then there is a complex. This is void, this is D, right? Then there is a closing of the class. So this is the constructor is used. This is closing of the class. Now this is the definition of the constructor, that is complex, sum, complex, sum, there is a complex C1, then complex C2, then there is a closing curly braces, then there is a complex C3, then C3 dot x equals to C1 dot x plus C1 dot or C2 dot x, then C3 dot y equals to C1 dot y plus C2 dot y. Then there is a return C3, right? Then there is a closing of this one, that is a closing of this function. Now there is a void show function that is used, that is a void show. Then there is a complex C. Then this is the definition of this function, that is the C out, then C dot x, then plus j, then C dot y, then there is a slash n. Then there is a closing of this show function. Then there is a int main. Then there is a closing of this one, that is a complex C dot x, sorry, complex capital A, that is given the value. So this is a parameterized constructor, that is 2.7 for example, and then 3.5 for example. Then one more is used, that is a complex, that is a B, then 1.5 for example, This is also closed with the semicolon. This is also closed with the semicolon, right? Then there is a complex, then there is a C, then defines the value, that is C equals to sum, then A comma B, then C out, that is A equals to then there is a show, that is a show function is called, then it is defined over here, then again C out, then B will be shown, then again show B, then again C out, then C equals to, then again show C, then defines the value, or the second method to defines the value, and another method to defines the value if it is applicable. If not, then simply assigns the value or simply gives the value. Then this is used for the next line, that is C out, that is /n, right? Then C out, then P equals to, then there is a show P, then C out, Q equals to, then there is a show if I've used this one, this is already printed, so this I'm not taking this one. If I delete or if I clear this one, this will be clear. I'll simply no got it, get ch, and there is a return 0. Then there is a closing of this one. These are the three modifiers, and there is the CLR, SCR. Now, if I compile this code, there are 4 errors. Unknown processor directive include. The spelling of the include is wrong. Now, if I compile, there is only one error, undefined symbol C. This is not in small letter, this is in capital letters. If I compile, there is no error. If I execute this code, A equals to 2.7 plus J 3.5, then B equals to 1.5 plus J 1.5, then C equals to addition of the both these, that is a 2.7 plus 1.5 is 4.2, and the 3.5 plus 1.5 is 5. So this is the addition of the A and the B. So this is the program that shows how the complex number will be printed by using the overloaded constructors, that is more than one constructor at the same time, or more than one constructor are using in the same program, that is a overloaded constructors, right? So now let's see what is the program about, or what the program says, that is a overloaded constructors. If I change the value, that also changes the number, that also changes the complex number. So first of all, understand the program. This is a hash include iostream.h, that is the header file will be included, that is the iostream.h, and there is a conio.h, that means the for the showing the output, for showing the using the clear screen, there is a conio.h, right? Then there is a class that is declared, that is a complex, so the name of the class is complex. Then there is a float, that is a part of the data member, that is a part of the private member, that is a float xy, right? Then there is a public complex, that is in a public part, that is defined, that is a complex, that is a default constructor, that is the first constructor that does not contain any value. So there are three constructors that is used. One is this one is this one is this one. How do I know these are the all three are the constructors? Because its name is same as the class name. So it's a constructor. There is a complex, then there is a default constructor. That means there is no value that is given, that is a default constructor. Then complex float a, that means the argument that is given a, that is a float type. Then x and the y are assigned to the value a. So whatever the value of a, that will be assigned to both the x and the y, the same value. Then float complex float real imaginary. That means if there are two values that is passing, that is a float type again. One is a real part, one is a imaginary part. So real part is assigned to the x and the imaginary part is assigned to the y. That is the real and the imaginary. Then there is a friend function that is used, that is a friend complex sum complex complex. That is a friend function is used. There is a complex that is used, and then there is a sum, then complex complex. Then there is a friend void show complex. So there is a friend function, that is a keyword that is used, that is a complex. Then there is a sum, then complex complex, then friend void show complex. That is the return type is void, and the show is the name of the function that is used, and the return type is complex. Then there is the closing of the class, and there is a closing of the semicolon, that is the closing of the class, right? Then these are the various declaration. So there are three constructors that is used. One is the one argument constructor, one is a default constructor, one is the two argument constructor, and there are two friend function that is used, that is a complex sum, then void show complex, and there is a closing of the class, there is a closing of the class function, and there is a closing of the semicolon. Then it is the definition of the function, that is a complex sum. So complex is the name of the we can say constructor. Then there is a sum, that is a sum, this is sum. Then there is a complex C1. So these are the two variables that is used, that is the C1 and the C2. Then there is a complex C3, that is C3 is another object that is taken of the complex class, that is complex C3. So C3 is the object that is used to access the value of the C1 and the C2. So C3.x equals to C1.x plus C2.x. That is, it is given, or it is taking the value of C1.x plus the C2.x. That is a C3.x. In the same way, C3.y equals to C1.y plus C2.y. Then there is a return C3. That is, the value will be returned, that is the return C3. So this is the definition of the friend function, that is a sum function that contains C3 value, C3 equals to 1, then return C3. Then there is a void show, that is a show function will be declared, that is a void show complex C. It simply prints the value or shows the complex number how it is printed. First of all, the C.x, whatever the value that is given in C.x, then plus J, then C.y. Then there is a next line. So this will be printed the values of the x and the y. Then there is a int main. Now, how do compiler know which constructor will be used as at the runtime? Either it is used as a 2.7, 3.5, either it is using the 1.5, either it is using no constructor. So how it will be used? So when the first object is created, that is the A, that contains 2.7 and the 3.5. So whenever this is used, so it directly moves the cursor to over here. Where? To over here. Why? Because there are two values that is assigned in this constructor only. Other, this is only one value. These are the two values. One is the real and the one is the imaginary. There are two values. These are the two values that is given. So it is directly jumped to this one, not to one argument constructor, but to the two argument constructor, because here two values are assigned. Then complex B, then there is only one constructor, there is only one argument that is used, that is 1.5. So this is used over here, like float A, that is only one value, one argument that is used. So When there are two arguments, so the constructor will be called, that is the two argument constructor. When there is only one argument, one value that is assigned, one is value that is used, so there is a constructor with only one argument, right? Then simply complex C, there is no value, that means the default constructor is used, that is a zero constructor with the no argument, like this one. Then there is a clear screen, that is CLR, SCR, then C equals to sum AB. Now the sum function will be used and the value will be stored in the C variable. So this is sum AB, this is the sum, this value will be stored over here. There is a complex C3, then C3 dot x equals to C1 dot x plus C2 dot x, then C3 dot y equals to C1 dot y plus C2 dot y. Then a cout simply prints the value of A, B, C by using the show function. So whenever the first line will be used, that the show A, it directly moves the cursor to this one. That is the show A function will be used. That is the showing the functions. Then show B, again showing the function. Show C, that is also showing the functions, right? Then there is a get CS, there is a return 0. So this is the program that shows how the constructor, or how to overload the various constructors, that is how to use multiple constructors at the same time, right? Now I have to So I will save this program with the use of overload constructor. Now this program is clear to you, each and every one. Yeah, this program is clear to each and every one. Hello. All right. So let's stop the class over here only. In the next class, I will be taking your next chapter, next topic, that is our multi-level inheritance. So that's all for today's session. Now, if there is any doubts, any confusions, you can ask from me. And any doubts, you can feel free to ask from me. So thanks a lot everyone for listening me. Bye bye.